Hello everyone, I am Dr. Sonali. I welcome you all to CSC Core Concepts. In this compiler design series, we are going to next start with parser. As we understand what is a parser, we can also call it as a syntactic analysis. In my earlier videos, I have discussed about the lexical analysis, which was the first phase of the compiler design. Now we move on to the second phase where the lexical analyzer and the parser, they work hand in hand. So as you can see from this figure, you can observe that this is the source program which is going into the lexical analyzer. Now this work is done in a parallel way, that is each token is been fetched and given to the parser, for which it generates a parse tree, and one by one tokens are going. Let us say for example, if you have a code called as id plus id, so the first token will go to the parser. The first token, that is id, will go to the parser. After applying it in the parse tree, the second token plus will be fetched, and the third one, and so on. And all these phases do require the symbol table. So we have discussed about the various phases in brief, and of course about your lexical analysis in detail. So now we move on to understand what is a parser, right? So as I told you, it is also called as the syntactic analysis, that it understands the syntax or checks the syntax of the code. Now basically there are two types of parsing. One is the top down parsing, and second is the bottom up parsing. And you can see the table here, okay, where you have two types of top down parser. One is with full backtracking, another is without backtracking. So in backtracking we have two types of parser: recursive descent and non-recursive descent parsers. They are also called as the LL1 parser. In bottom up parser, or they are also called as SR parser. SR means shift reduce parser. Okay, so there are two types of parser: operator precedence and LR parsers. In LR, you have different types of parsers like LR0, SLR, CLR, and LALR. They are the variations of this LR0 parser. In this video, I am going to teach you about the top-down parsing. Let us understand it. And thereafter, we are going to start with the first type of top-down parser, that is with backtracking. Now, let us assume we want to construct a parse tree. So basically, what is a parse tree? It is a tree where there is something called as the root node. Of course, this root node symbolizes the start symbol, and this goes down to the leaves. Now, if you use the leftmost derivation, so I have a grammar, S is AA, let's say. So if you go by the leftmost derivation, and we are going to expand all the non-terminals, let's say A is A or it is epsilon. Let's say, for example, this is my grammar. So S is my start symbol, and I have two non-terminals here, S and A, right? And I am going to employ recursive descent or LL1 parsing or any type of parsing to expand this left side, that is the non-terminal. Let us say a grammar, okay. So consider this grammar A, B, and C. Let's say this is C. And this is either A, B, C or A, and B is D. Okay. This is a grammar where I want to generate a parse tree considering this string A, B, C, D, and E. Okay. Using a top-down approach. So always you have to start with the start symbol, that is the S, and start with the production rule. What is the production rule of S? We can see what is the string we want here. We want A, B, C, D, and E. Okay, so this was your E, right? So this is the string I want. My string is, my S is what? A, capital B, and E, right? Now, if you realize, if you compare these two, this production rule and this input string, The first symbol is matching, yes, and the last symbol is matching, yes. So let me expand this production rule in my case. So if I expand this, this is my root node. Okay, and I am expanding A, B, E. So if I look the string for which I want to do the parsing, my A and E are done. Now next what I want to do is that I want to expand these terminal nodes, right? A and B. So let us say expansion if I do in the linear form. If I tell you to solve this grammar, what will you do? You will replace this A with the rule which A had. The rule for A was A, B, C or A. Now because I want this BC, right? I will have to consider this first rule. So if you go here, go back here, so this A will be replaced by ABC and BE, right? Now if I replace this A with the A which was there, right? So I get A, B, C, D and E, right? So if I want to implement it here, how will I do is that here I have the rule A, B, C, right? And this one is your D. Now I want A, B, C, D and E. I want double A, B, C, D and E. This is my string. So where will I get this again A from? From here, because this A is following another A. Right. So you can see here is that at every point the leftmost non-terminal symbols are expanded. Okay, so these are our nodes. That is why I call them terminal nodes. In a tree, they are called as nodes. But if you talk about the grammar, this A and B are your non-terminals, right? So you can see at every step we are expanding the non-terminals. So in the top-down approach, leftmost is mostly expanded. Now here we observed that for this S, A, B, E, okay, then A takes the form of A, B, C or A. So you have two rules here, right? Either A can take the form of this or this. Now how did you decide that you want to consider this rule first and then this rule? Because you have seen the string and as human beings you can understand that this BC you want, and so you have to expand this rule first and then this one. This confusion is because there are multiple rules for A, right? But how will the parser determine which rule has to be used? So this is a very important question, that when you have multiple rules, how will the system or the compiler decide that which rule has to be used? So let us take one of our popular approach of top-down parsing, that is backtracking, in which the parser will attempt one by one rules. If there are multiple rules, it will try to find out one by one rules and apply and check whether it got the input string or not. But in case it does not work, here with backtracking, it can undo that shift. This is possible in backtracking. So let us see what are the key steps of backtracking. So the key steps of backtracking is that first you have to choose a non-terminal from the current production to expand, right? Apply rule whichever is possible. First rule. Okay, if you have multiple rules, go by the first rule, apply it. Then if you see that this rule is okay, it is doing, or if you can further expand, like we expanded, right? A. So this A could further be expanded. So if a further expansion is possible, then do that and apply the rules. But in case with these expansions you are not getting your desired output, then you may go back. You can go back and perform backtracking. So in case of a failure, that you fail to get the desired rule, desired string, then you can always backtrack and keep on trying all the alternatives until all the rules are over or you get your best possible match. So let us consider this grammar where S is CAD and A has AB or A. So you can see there are multiple rules. Now parser will get confused that here in this A, which one it should follow, AB or A, right? That is a question. So I am giving you a string called CAD, and for this string CAD I require this. So let us get started with the first input start symbol S. So let us create, because S has only one rule, so there you don't have to make any decision. So it is S to CAD done. Now when it's time to expand A, which rule are you going to apply? That is a question. So let us get started with the first rule, that is A and B. Okay, let's say AB. Now see if you get the string or not. So if you follow A with A and B, and then the string which you are getting is CABD. CABD. Is it matching with your input string which has been given to you? Of course not. So that means what this rule, that is the decision for applying A to AB, has not worked here. So in this case we can again go back, which is possible in this backtracking method. So you again go back to A and undo this, that I don't want to expand this, and now I will try with the next rule. So if you get a mismatch, you backtrack. Okay, so you try for rule 2, that is replace A with smaller a, and here if you do so, you get your desired string CAD, which is done. So there is a success over here, right? So I am giving you another grammar. Consider this grammar where S has multiple rules. S is CABD or BAC. A and B all have multiple rules. I want my input string to be BDAC. Will you be able to solve it? If, please try and write the answer in the comment. So how are you going to start with your S, that is the start symbol, and keep on trying with the first rule, let's say CABD. Now we have to do recursive expansion, that is these non-terminals have to be expanded. Now which rule? Again A has multiple rules and B has multiple rules. So which one you are going to apply, we don't know. But again here one thing is a problem, that the first symbol is also not matching. B is not matching. Here the first symbol which we are getting is C, here it is B. So let us backtrack, okay, and try S with the second rule, that is capital B A C. So the first level only you have undone, right? Now again your first letter is B. Let us do a recursive expansion. So for B again you have multiple rules AC. Let's apply first AC. Will it work? No, you want B here. So again backtrack and try this B with a different rule, that is the next rule DA. Does it work? No, still you want B. So let us try B with the next rule, that is our, what one is B and D. So now you can see over here I am applying S was, you applied the first rule BAC, right? Now this B you expanded with the third rule, that is B and D, right? So now you did you get your string B D A C? So you got a success by applying this rule. So how many attempts we had to do? First we tried with S with the first rule, it did not work, so we had to backtrack back to S, applied the second rule, it worked, but again we had to expand this non-terminal. We tried it with the first rule AC, did not work, backtrack, tried with the second one DA, did not work, backtrack. When we tried with the third one, it worked. So you go on implementing it, go on applying until you get all the rules, or let's say in some cases, even after applying all the rules, you may not get the desired result. So there you are going to stop. So I hope you understood the first process of top-down parsing, that is a backtracking. In my next video, we are going to discuss about some more interesting top-down parsers which are without backtracking, where you do not have the provision of backtracking, so you cannot apply different rules and see and check. So you have to be very sure about the rule. Now, how can you be very sure about the rule which to apply? That we are going to discuss, right? So don't forget to like, share and subscribe and press the notification button so that you can get a notification when the new video is uploaded. Thank you.